All right, guys, I'm going to try and help you out on Wednesday's topic, which I believe carries into Thursday, which is kind of doing the opposite of what you did yesterday. Yesterday, you did a whole number divided by a unit fraction. Now it's a unit fraction that we're starting with, dividing it by a whole number. So again, you have to think about this as a number sentence. This is the amount that we're starting with, and this is now the action that we're doing to it. So first, I need to get the amount that we're starting with. If I take a look at this candy bar down here, I'm not looking at a half of a candy bar, I'm looking at a whole candy bar. So the first thing I need to do is split this whole into the unit fraction, which is half. I'm going to go ahead and do that. I'm going to divide it into two equal groups, okay? And so now I'm starting with a half. So essentially the part of this candy bar that I'm looking at is this half right here. The other half will matter, but we're focused on this one piece. So here we go. Now I need to take that half and I need to divide it into 4 equal pieces because that's the action that's happening. So I'm going to go ahead and divide it into 4 equal pieces. Everyone keeps doing these vertical lines. Do whatever makes sense to you. Like for me, that's an easier way to divide that into 4 equal pieces. Now, what we've done is we've taken that 1/2 and we've divided it into 4 equal pieces, and we want to see what we have. But we can't just stop there because fractions and division in general is dividing into equal groups. And if you take a look, the piece that I shaded here, the size of that piece is absolutely not the same as the other half of the candy bar. So if I'm going to split one of my halves into 4, I need to do the same thing to my other half. So I'm going to take my other half and I'm going to divide it into 4 also. Now you can see that I have equal pieces. And so now if I'm looking at what fraction of the entire candy bar is shaded, you can see I have 1 piece shaded. So that's going to be the numerator of my answer. And then if you count all the pieces, 1, 2, 3, 4, 5, 6, 7, 8, I can see there's 8 pieces in the candy bar altogether. So starting with 1/2, when you divided it into don't listen to what I said. If you divide it into 4 equal pieces, you end up with 1/8 of the entire candy bar. Okay. Now that's like kind of the understanding piece of it, but there's always shortcuts. So if you're really struggling, this will be something you learn again in 6th grade and 7th grade. So if you need to stick to the shortcut, fine. I'm going to show you keep, change, flip, KCF. Keep means that you don't do anything to that first part of your number sentence. So 1/2 is going to stay the same. Change means we are going to change the operation to the opposite or the inverse. Well, the opposite of division is multiplication. So I'm going to change that to multiplication. And flip means I'm going to take the numerator and the denominator and I'm going to flip them around. Well, if you look at our thing that we're going to flip, it's only a whole number. It doesn't have a numerator and denominator. What you need to remember is the whole number 4, if I wanted to turn it into a fraction, that would simply be the numerator and my denominator would be a 1 because that means 4 divided by 1, which is 4, means the same thing. So now I have 4 over 1. If I'm going to flip that, I'm going to have the 1 on top and the 4 on the bottom. And so now we've turned kind of a confusing division problem into a multiplication of fraction problem. Sorry, my words aren't working this morning. In which case, multiplying fractions is the easiest of all the operations. All you do, I'm just going to grab a different color pen here. All you do is you go numerator times numerator. So 1 times 1 is 1. And denominator times denominator, 2 times 4 is 8. And so you can see we end up with 1/8, which if you think back to the long way, the model way, we got the same answer. I'm going to go ahead and do at least one more to help you. And I might have to move my face here. There we go. Okay, so I have 1/4 divided by 5. So what that means is I am starting with 1/4. So I'm going to take my fraction, or excuse me, my whole object here, and I'm going to divide it into 4 equal pieces so that I can focus on this 1/4. That's where my answer is going to be. Now I'm going to have to work with the whole thing, but I'm focusing on that 4th here. And what I need to do is I need to divide that 4th, which is right here, into 5 equal groups. So I'm gonna go ahead and do that. I'm gonna do 1, 2, 3, 4, 5. And if I look, I'm focusing on one of those fifths. So this is where my final answer is going to be. But the problem is, if I want to know what fraction is shaded, fractions mean all the pieces need to be equal sizes. So if I'm going to divide that fourth into 5, I need to make sure I'm dividing this fourth into 5, and I'm dividing this fourth into 5, and I'm dividing this fourth into 5, to determine what fraction I have shaded. So you can see I have one piece shaded, but I have to figure out how many small pieces there are all together. Well, there's 5 and 5 and 5 and 5. 5 plus 5 plus 5 plus 5, or 5 times 4 is 20. And so my final answer would be that if I have 1/4 and I divide it by 5, I'm going to end up with 1/20th of the whole thing. Okay, that's the long way. If that makes sense to you, awesome. If it doesn't, we're going to stick with the shortcut for now, and you'll revisit this in future grades. Keep, change, flip. So keep means we're keeping that 1/4 the same. The change means we're going to use the opposite of division. So we're going to use multiplication, which is so much easier. We've always liked multiplication easier than division, even now with fractions. And for flip, we need to take the numerator and denominator and flip them around. But we know that 5 doesn't have a numerator and denominator. But another way to kind of think about 5 is 5 is your numerator over 1. This means the same thing as 5 because that means 5 divided by 1, which is still 5. So if I flip 5 over 1 and I flip them around, the 1 is up here and the 5 is down here, which means we've turned a really confusing division of fractions problem into a multiplication, which is a piece of cake. I'm just going to grab a different color pen here. We've got straight across, 1 times 1 is 1, 4 times 5 is 20. And what I didn't mention before is we always have to make sure our answer is in simplest form. What's nice about working with unit fractions is the numerator is a 1. It's 1 and done. So if you take a look, whether or not you used the model or you used keep, change, flip, you're going to end up with the same answer. I'm going to just do one more with keep, change, flip, because I think that might be something many of you guys are going to rely on. If you like the model better, reach out to me and I will put a new video together for you just with the model. But let's just look at keep, change, flip. Keep, 1/3 stays the same. Change, that division turns into multiplication. And flip means we're going to flip the numerator and denominator around. We have to remember that 6, the whole number, is the same thing as 6 over 1, because that's 6 divided by 1, which is the same as 6. So if I have 6 and 1, if I flip them, it's now 1 and 6. So I'm going to make my numerator a 1, my denominator a 6, and I'm just going to grab a different color here. Multiplying is so easy. Across, across. 1 times 1 is 1. That's my numerator. 3 times 6 is 18. And it is already in simplest form. So if I have 1/3 of a cookie and I divide that 1/3 of a cookie and share it with 6 people, they're each only going to get 1/18 of a cookie, a really small piece. Hopefully this helped clear up today. If you need any more help, please just ask. I'm here always, not going anywhere.